You are now listening to the EU Startups Podcast.
I'm now joined by Julien, the CEO of Coldpad. Welcome, Julien.
Thank you.
No, thank you for joining us here today. I was hoping that before we get into the questions, you could give me a quick summary of what Coldpad does, the innovation you're presenting, and maybe even the background of how it began.
Okay. So Coldpad, we are an engineering company. We have been founded 14 years ago. And what we are doing is we have developed a way of bonding which gives you fasteners, so to install stuff, via bonding with strengths which are as high as what you can find with welding or bolting. So basically, we replace making holes or welding stuff by just bonding it. So actually, it has been at the beginning created in the oil and gas industry because on the oil and gas asset, you are explosive everywhere. Which means that you cannot do hot works because it's problematic for safety. So this is where we started. And from this point, we started to develop in other areas like buildings, in particular nuclear power plants, but also in aero, in space, and also in wind industry.
Okay. Well, talk me through what was that. How did you initially come to seeing that there was a problem in this industry, and how did you get to the point of developing this kind of technology that would address it?
At the really big beginning, the founder was a structural engineer on an oil and gas ship, which is called FPSO. This is where you extract oil and you start to process it. And every time they needed to make maintenance work, they needed to stop the ship. And this ship, they have a daily turnover of around 4 million euros for the biggest one. So every day of day off for maintenance reason, they were losing 4 million euros. And so this is why he came up with this idea to find something where he was able to make this maintenance without downtime. So he really started by that. And it was a very kind of oil and gas thinking, with the best product, the best quality, the best capacity. And from time to time, we developed the product in order to make them cheaper for other industries, but also easier to install or to use.
Okay. Well, I've through your marketing materials, I keep seeing the no drilling, no welding, no hot works. Explain to me why that's such an important angle of what you're offering. Why is that such what I imagine, a way of selling the technology to your clients? Why is it?
Exactly. It's a good point. It's when you weld or when you drill, basically you are interfering with the structure on which you are working. For instance, if you are on a ship, obviously you don't want to drill on the hull. It's obvious, but also you don't want to weld because you are going to damage the steel structure of the hull. So drilling something or welding something, it's always what we call invasive, intrusive. It means that you are going really to damage the substrate on which you are working. So when we talk with the professional of all the sector with whom we are working right now, they always say, okay, we need to find another way of installing our equipment without damaging this structure. So it's true for steel, but it's also true for concrete. For instance, when you take high-end concrete like reinforced concrete or pre-stressed concrete, I mean, if you make a hole on it in order to install a dowel, for instance, for a reinforced concrete, if you touch the rebar, then you will be into troubles because you are going to damage the own structure of the wall. So this is why when we talk with people working with this kind of buildings, they are very interested because we are really making their life easier.
And what, is there a safety angle to this as well? that you can pitch to say this is an improvement as to the structures, is improving to any reparations you're doing that's going to improve safety conditions?
Yes.
Okay.
You definitely have it's safer for the worker. In particular, when you want to make a hole in high-grade concrete, so you need to use your power tool, and the vibration are very harmful for the worker. As we are bonding everything, there is no vibration. It's very quick for the worker. So actually, for their own safety, for their health, it's obviously better. Another interesting point is that because we are bonding and we are not making extra dust. So also dust can be CMR. It's also bad for us. So in our cases, when you use our technology, I mean, it's better for this aspect. So actually, we were a finalist of Electricity of France, EDF. We were on one of their Pulse conquest, and they selected us because of safety, rather than structural transparency.
Okay. Well, I think it's important for really anybody who's watching this podcast as well to have an understanding of a real-world application. Do you have a specific example you could give me of a project that utilized your technology and it substantially improved it?
Yeah. So let's talk about maybe one example for steel and one example for concrete.
Sure.
So for steel, we are widely used for wind tower, so for wind turbine. Okay. When you take a wind turbine, so you have the tower which is made of steel. The steel is structural, so it's like a cannon, so it's like a tube, it's like a pipe. And if you want to install inside this tower the ladders, the cable trays, the intermediate platform, I mean, usually most of the customer are welding what they call bushes in order to screw and attach all the ladders, cable trays, etc. on the tower. But when you do that, actually, structurally speaking, you are weakening the tower. Because when you weld on a 100 meters height tower, actually it is very sensitive to the fatigue stress. And when you weld, I mean, you make it worse. So by using our products, you bond it directly on steel. It is qualified for 35 years, so more than the design life of the tower. And so you can actually stop welding. So you are using less steel, because when you weld, you got to put extra steel in order to make it better because of this welding. But now there is no welding anymore. So you can save steel, which means that you are saving money because there is less steel, but you are also saving CO2. Because, I mean, every ton of steel produced is a huge amount of CO2. It's 1.8 times of the steel that you are making. So, I mean, you are winning on every level. Let's take another example, which is a nuclear power plant. So we have a concrete product. And when we released it for the first time, it was 2 years ago, and EDF, Electricity of France, was facing major issues in their nuclear power plant. They were having issues with pipes, what they called corrosion under constraints. And in the nuclear building, they needed to replace these pipes. The issue is that on the nuclear building, you are not allowed to make holes everywhere, obviously, because you need to make sure that you are not damaging the structure. And so what they did is they use our technology in order to attach all the pipes that were damaged, cut them, put them on the floor, and then reinstall them, so using our technology as anchor points in order to lift it. And so they have been able to make it straight away with absolutely no damage on the structure. And also another important point is that our technology is so easy to use that you don't need to have a super skilled worker. And the issue that EDF was facing is that a worker in the nuclear building can only work a certain amount of hours per year because of the radiation. And so they were starting to lack of skilled worker in order to make this work. But thanks to our techno, which is again very easy to use, they were able to use every worker skilled for nuclear power plant, obviously, but you didn't need to use special welders or special workers. And so they have been able to make this maintenance even faster thanks to Coldpad techno.
I find it interesting because you've touched on saving resources. Immediately that makes me think of sustainability. And how much of that is a selling point of your technology? Do you use that as a way of marketing what you do? Are potential clients interested in that side of the application where they can save resources by using your technology?
It's a very good question. At the beginning, and in particular when we were in oil and gas or nuclear industry, it was all about planning. So all about saving time and saving resources. It was all about that. Whatever the price, when you saved 1 day on an oil and gas ship, as I said, it's a huge amount of money. So it was everything about time saving. But now that we are working for industries like civil engineering, like wind energy, or even for planes, they are definitely concerned by cost. So when we moved from this energy industry to more building industry, we needed to also make products that are not only saving time but also direct cost.
Okay.
So this is what we did, and so now, these two angles are important in order to market it to the professional of the civil engineering industry.
Okay, and as a company, it's been around, you said 14 years, is that right? I have to wonder because you have a physical product, something that's very much can put in your hands. Somebody who's listening to a podcast can't see it, but it's there in front of me. How has that evolved from maybe the initial design into what it is now? And do you see it, what avenues are there for potential improvement or application?
Yeah, okay. So the really first product that we developed, again, it was used for oil and gas, and it was all about performance. So the strength, the resistance of the anchor point that we developed was actually 12 tons. So when we are bonding our first iteration of products, we are able to sustain 12 tons of loads. But as I said, when we started to expand in the other industry, these 12 tons, it was not the point of our customer. So what we did is we made some interviews of professional people, and we asked them, what is the perfect load that you want to reach with products such as ours? In other words, what is the load that you are targeting that will reach 95% of your application? And the first answer was 300 kg, 300 kilo. So coming from a very, 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 let's say, high-end products, we targeted this 300 kilo of permanent load. And so we basically downsize our products in order to make them lighter, with fewer materials like stainless steel, and also with installation tool smaller. And so we went really in the direction of small is beautiful. So we really downsize everything, and now everything can be stored in a small suitcase. So it's like any other power tools that you can find in civil engineering. And we have a weight of about 100 grams for our product, which makes them completely transparent in terms of weight when you are installing it somewhere.
Okay. Well, out of these, or maybe you haven't mentioned it, but what would you say was the kind of most difficult breakthrough or the most difficult kind of learning pain that you had to go through?
Yeah, I mean, first it was convincing the majority of people. I mean, everybody, when we were a child, I mean, we all try to fix our toys by gluing them, and it never worked. So I mean, everybody has experienced bad bonding. So I mean, the first, let's say, the first thing that you need to address is to explain people why this time it's going to work. Obviously, we have our qualification. So we are qualified by Bureau Veritas in France, by American Bureau of Shipping in US, by DNV in Germany and Norway. We also have a European technical evaluation, so made by Europe. So we have all the qualification, of course. But the first point is really to explain people why it's working. In terms of engineering point of view, the second point is about design life. You have a lot of glue, adhesive techno everywhere, but they are not made for permanent application. Okay. What we see on the market is that you can use it for months or years, but if it's years, you need to be in a dry environment, inside, etc. And so, what we really achieve is to qualify it for decades. So our steel product is qualified for 35 years in maritime environment. So in in an environment with humidity, which is the first. And our concrete product is qualified for 50 years on concrete. So it means that basically when you use it, you can consider it as a permanent installation, which is, it's completely unique today in the world.
Well, you mentioned that you were certified as well in the US, and that makes me think about kind of the international application of what you're doing. How much do you feel technology applies in Europe versus the US? Do you feel there's more of a market here than there? What's the opinion on that?
I think that, our turnover in US is not that high, actually. We are more developed in more in Asia, in Africa, in South America, and in Europe. US, US, we needed to be qualified by US authorities because in the oil and gas market, they are very strong and they raise everywhere in the world. So it's more in this aspect. Okay. For instance, when you are making an oil and gas ship, 80% of them are qualified by the US authorities, rather than Bureau Veritas. And so this is why we needed to be qualified for US. But definitely, US is one of our targeted segments, and this is where we want to develop in the next years.
Okay. Well, I've already done a few interviews with fellow companies and cohorts, and there's the defining line, obviously, of high tech, right? There's a lot of use, and you stand out to me as one of the ones that don't have that kind of implementation. I've got some numbers here. Well, just that we've seen a lot of funding from EU startups gone into technology, gone into AI. Does that make it harder to explain Coldpad's value to potential clients, or does it make it easier because you kind of stand out automatically from other companies in the space?
So we do stand up.
Okay.
Stand out, sorry. Yes. When we are in a gathering of startups or new tech, indeed, it's very often about artificial intelligence, about software, about so when we bring, let's say, hardware, some things that you can touch, there is two interests. The first one is that you can explain it quite easily, so people understand. When you say, okay, with our tech, you stop welding, you stop drilling, you bond. People understand the concept and they understand it. The other point is for people who are working on the field. It's not a concept. It's something that they are experiencing every day. So actually, it's very often easier, and actually, I'm very happy to be here today, is that we are in contact with operational people. And when you talk to them and when you say, okay, we are going to give away a burden that you have when you are making holes, for instance, they understand it. And so they are our best supporters.
Okay. Well, I think as a final question here, and I think naturally the final question is always about the future. So mine is more tuned to the idea of aging infrastructure. Because you're talking about maintenance now, and I just want to hear about what Coldpad's view is on as infrastructure ages, right? And I understand that maintenance becomes more difficult. How do you see your technology adapting to that 5 years from now, 10 years from now?
Okay. So yes, our next step for aging infrastructure, it's about thermal efficiency. In Europe, in US, in Japan, we are having whole buildings, aging buildings, which have been made 10, 20, 30 years ago, and in terms of thermal efficiency, which are very poor. So we are seeing today a trend about facade cladding, which means that you are going to put some panels panels and insulation in order to insulate these buildings. So this is our probably next innovation. It's to be able to make it cheaper, easier, and faster using our bonding technology. Today, it's very expensive. Today, if you want to put this insulation with the facade cladding, if you want to have panels which are free of holes, you don't want to see 4 holes on every of your panels that you put on your wall, the cost is huge. It's around 300 euro per meter square. 300 euro per meter square in order to make it good looking. So they have solution, but it's so expensive. And if you look at market like Europe, we are going to have millions of meter square of facade to insulate. And so right now we are working on bonded solution that you will be able to use and that we probably divide the cost by 2. So this is definitely where we are heading to today.
Okay. Well, thank you very much. It's been a pleasure to talk to you.
Thank you very much for this.
Thanks.
Thanks.